All right, stats. This is going to be your last video for your exam number 3 for whenever I see you again. For this, if you guys don't have one in your possession, just Google T-Table PDF. The one that I printed out, the one I used here, the really good ones from University of Regina in Canada, not Canada, in Canada. Okay, so just Google that, and that's the one I clicked on. That's the really good one. All right, anyway, sample of 25 5K times for runner A, had a sample mean of that, with the sample standard deviation of that. Random sample of that many 5K times for runner B, had a sample mean of that, with the sample standard deviation of that. Compute 95% confidence intervals for the population mean, and comment on whether runner A has a chance of beating runner B. I did this example a few years ago in a master's class with one of my running buddies who I'd never beaten before. And we did the math to see if I had a chance, and it came up that I did have a chance, and eventually was able to get him. Anyway, so can this happen? Let's root for the slower of the two runners, runner A. Anyway, degrees of freedom 24, 2.064, is for a 95% confidence interval. Degrees of freedom 24, that is your T star. Just look that up. At the top, it was like confidence around 95%. Degrees of freedom 24, that is my number. Standard deviation, square root of sample size. All right, instead of Z star, we're just doing T star. 0.19, subtract it and add it. All right, so that's the, remember, low score wins here. That is the slowest that they could possibly go. That's the, on average, that's the height, that's the fastest they could possibly go. All right, runner B, the quicker of the two, it looks like. 2.056. All right, that is degrees of freedom 26, 95% confidence interval. That's your T star. And on the very fast end, 16.59. No way runner A can touch that. But on the low end, 17.03. So runner B, having a slower day, could get beat by runner B. Runner B having a slower day could get beat by runner A having a faster day. There is overlap, no clear winner. Slow runner A has a chance. Yes, could happen. How well materials conduct heat matters when designing homes, for example. Conductivity is measured in terms of watts of heat power transmitted per square meter of surface per degree Celsius of temperature difference on two sides of the material. Holy cow. In these units, glass has conductivity of 1. National Institute of Standards and Technology, NIST, provides data on properties of material. Here are 21 measurements. So, list 1, that's what I got, X bar 1.10. Now, because you're dealing with such a low number, I would round standard deviation to 3 decimals. That's what I did here. Okay, you got degrees of freedom 20. You want 95% confidence interval. The Z star there, or T star there is 2.086. All right. Doesn't matter how you round, you're going to get 020 or 02. And that is it. Nothing really to be said there. I don't know, this printed a little odd there. Math department believes that its undergraduates have a cumulative GPA better than 3.20 on a 4.0 scale. Sample of 25 of its undergraduate students has a sample mean of that. So they do have a better GPA than that, but is it statistically significant of enough of a result? Standard deviation of that. Test their claim. That's a big standard deviation in terms of GPA. Test their claim at 0.031 for alpha. One-tailed test, the alpha is 0.01. Degrees of freedom is 24. All right, so you go, one single tail, alpha is 0.01. You go down to degrees of freedom 24. Your rejection region begins with a T score of 2.493. T is equal to sample mean divided by, or minus the proposed mean divided by standard deviation, or the square root of n. 1.15. You fail to reject, the null hypothesis and say, nope, their GPA is not better than. It's at 3.20, or it could be less. Company claims that its product's failure time is at least 200 days. Ran a sample of 200 of these, or 22 of these products, reveals a sample mean. It's definitely less than 200 days, but the standard deviation is quite high. Test their claim at alpha is 0.05. So they said at least 200. That is greater than or equal to 200. So the null hypothesis is that the alternative hypothesis is less than 200. Sample did come up pretty short. Degrees of freedom 21. Alpha is 0.05. One-tailed test will give you a rejection region beginning with a t-score of negative 1.721. Here we go. So it did come up short, but is it short enough to say they are lying? And it does not. You get a test out of negative 1.26. Not statistically significant enough. You fail to reject it and say that they're still allowed to make that claim, even though their sample was 10.5 days short on average. Wow. The mean pH in my fancy French water should be 8.40. Random sample of the last 18 waters I purchased has a sample pH that is short. That's not good. With a sample standard deviation of that. Test the claim of exactly pH of 8.40 at the 5% significance level. It should be exactly. This is a two-tailed test because it should be exact. Alpha is 0.05, two-tailed test, degrees of freedom 17, negative 2.110, positive 2.110. Calculate that test statistic. Sample mean minus the proposed mean divided by standard deviation over square root of sample size. Going to reject the null hypothesis and say that the mean is not 8.40. So go after him. All right, folks, that concludes your big test review. It is still a 2-day exam sometime in the future. Hopefully the relative future, but we shall see, folks. Keep reviewing this. I will give you a video later, probably on Monday, with the one last thing you can do with your project, and then honestly we're going to go from there. If this gets extended too much further, you might be doing some learning, folks, via video. You can make it happen. You guys are a college class. I believe in you. This is Yak Math Videos signing out.